Hello ladies and gentlemen, and welcome back to another lesson in Algebra 2. Today we're talking about graphing polynomials. Okay, so when we're graphing polynomials, you will notice a pattern taking place as we are working through this, okay? Here we have an odd polynomial. How I know it's odd? Because of the exponent right there is 5. So that makes it an odd polynomial. And it has an odd leading coefficient. How I know I have an odd leading coefficient? So the polynomial function is based off the largest exponent, and so then the leading coefficient is based off the coefficient attached to the leading degree. So here our y is going to be negative infinity, and x is going to be negative infinity. Y is going to be positive infinity, and x is going to be positive infinity as well. All right, so here below we have the equation 5 to the 5th power minus 5x cubed plus 4x. Okay, and so when we plug our numbers in, so what we're going to do is we're going to do negative 1.5 to the 5th power minus 5x to the 3rd power plus 4x. So we're just plugging the numbers in for each one. So when we do the first one, it will come out to be 3.28. There's my point right there. And then the next one is going to be negative 1.4. Okay. Then the next one is already positive 1.4. And then the 1.5 is going to be a negative 3.28. And then we have a positive 120. Now when we look over here where it says above, below, it's related to the interval. So a negative answer gave us a below. Positive gave us an above. So this negative is going to be a below. I'll just put a B for below. And the positive is going to be above. So I'll just put an A for above. So the next one is a negative, so it is below. And so the last one is positive, which means it's going to be above. All right. So when we graph it, this is what the graph actually looks like. If you see, it looks like a squiggly line. And when we're talking about odd degrees of polynomials, they are squiggly lines. If you have an even degree of polynomials, it will be a U shape, some form of a U shape. All right. Here, x-intercepts are. So x-intercepts means where it crosses the y-axis. So when we plug these into a graph, we are going to get the intercepts of negative 2, negative 1, 0, 1, and 2. All right, here's the next one. The graph goes to infinity of x as x goes to negative infinity, and negative infinity goes as x goes positive infinity. So we have the zeros of negative 2, or negative 1, 2, and 3. So that's where it crosses the x-axis. And we're going to have fx is blank into intervals. Okay, it is going to be positive in the intervals, and then it's going to be negative in the intervals. So between negative infinity to negative 1 and 2, 3, it is going to be positive. Then it is going to be negative from negative 1 to 2, 3, infinity. All right. Let's move to the next one. Okay, so this one here, use the zero product property to find its zeros. And so I believe this is a typo, because the degree is 4. And if the degree is 4, that means we're only going to have 3 curves. And so there will not be 4 x values. It's only going to be 3 x values. And so the multiplicity of 0 is the number of times the related linear factor appears in the factored form. Factored. F-A-C-T-O-R-E-D. There we go. Factored form. All right. Here's the pattern. So if we have x minus 3 or x plus 3, we're going to have a negative 3 when we make it equal to 0, which means we have an odd multiplicity. So it is just a plain straight line. This one here, we have, we set it equal to 0, comes out to be 1. We have an odd of 3, 5. So any odd number is going to be a squiggle or a shimmy. So it looks like, I call it an sideways S. Then if it's a square, it's an even number, which means it will touch or bounce off the x-axis. All right, so here we are looking at the pattern. So the degree of polynomial, so we're multiplying these two terms, we're going to add the exponents, back to the laws of exponents. So our degree of polynomial is 2 if we add those together, which means it will have 1 turning point. Okay, the next one, we have 3 we're going to multiply, so our degree of polynomial is 3, and it has 1, 2 turning points. Next one, we have 1, 2, and 1. So 1 plus 2 is 3, plus 1 is 4. And the turning points, we only have 1, 2, 3 turning points. All right, next one, we have 2 plus 2, which will give us 4. And we only have 3 turning points. So the pattern that you see is the number of turning points is 1 less than the degree of polynomials. So let's say the polynomial degree was 5. We would only have 4 turning points. So that is the relationship between these. And if it's an odd, you'll have an S shape. If it's an even, it will be either a U or W type form shape. All right, ladies and gentlemen, thank you for joining me in this lesson. I hope you come back for another lesson in Algebra 2. Have a wonderful day. Thank you.